Now, in the second part, we are going to examine the model which we've just created. Okay, and by default, the first one is Microsoft decision tree. Now, this is given here in the mining model, and the view we are using is Microsoft tree view. By default, the decision tree will load with 3 levels, but you can increase them to whichever number you like. Now, if you put your mouse on top of all, you'll find that we have a total number of cases of more than 17,000, and almost 50-50 people purchased and did not purchase a bike. The color, which is light blue, represent the people who have not purchased the bike, and the color which is pink represent people which have purchased the bike. If you look at the age group, the age which is more than 75 years old, you can see the light blue is way huge compared to the pink, which means that less people in this age group purchased a bike. And if you look at the age between 40 and 47, you will find that most people in this age group did purchase a bike. Now again, in the background, we can have background for all cases, or which represents people who have purchased the bike. And the more the blue it is, it means that the more people in that category have purchased the bike. For example, in the age group of below 40 and in the number of cars owned, people who do not have car, actually they've purchased more bikes than people who have cars. Okay, and again you can go to 0 and you'll find that this is the reverse of the previous one. Now, if for example you select a node, for example let's say age group between 40 and 47, and if you right click and you say drill through, then you can get the detailed view of the people who purchased or did not purchase bike in that particular node. So you can have a lot of information here in detail. Okay, but that's the job of drill through. Now, in top here we have a decision tree, and again we have dependence network. Dependence network will show the attributes, the link between the predictable attribute, which is bike buyer, and the other attributes around it. On the left, we have a bar, a slider, which shows all link. If I drag it to the bottom, it will give me only the strongest link. And in this case, we can see that age is the strongest link in predicting customers who are likely to buy a bike. And if I drag it a little bit up, the second strong attribute is number of cars owned. So the number of cars at home strongly determine the likelihood of people purchasing a bike. Okay, and number of children at home, yearly income, which is kipato, determine also, and the higher you go, the more attributes are included. And I will find that the last 2 attributes are English education and house owner. So if you have or have not, if you do own a house, or if you don't have a house, this is not a strong link between that and purchasing a bike. So if we go back to decision tree, you'll find that in this case, in this particular mining structure, in this particular mining model, age is the determinant, is the strong determinant in determining people in purchasing a bike. Now, we have seen how decision tree works, and let's move to clustering. Now, in choosing clustering, just go to mining model and select clustering, and automatically the clusters will come. Now, in the shading variable, we have to select bike buyer because we want to determine the groups which are likely to purchase bikes. And in the all links, I think let's put all links to full, the slider. Now, the state here is 0. 0 means that people or group of people who have not purchased the bike. The more the colorful it is, or the brighter it is, it means that these are the people, the group of people who have not purchased the bike. So let's, while it is 0, let's drag the very dark clusters on the right side, and this will represent the group which have not purchased bike. And the lighter side, let's move it to the left, and this will represent the clusters of people customers who did purchase the bike. So if we change here, we move from 0 to 1, then automatically it means that now the brighter or the more colorful it is, the group of people who have purchased the bike. Now, if I look clearly, I think cluster number 10 is the brightest, I think. So I'm going to actually, even if I put my mouse on top of cluster number 10, 67% of people in this cluster have purchased the bike, compared to, for example, in cluster number 7, where only 34% did purchase the bike. So I'm going to rename this and call it bike buyer high. It means those people who have purchased a bike in very high numbers. And then I'm going to change the state here from 1 to 0. Okay, and I think cluster number 7 or cluster number 9. Let me see. I think cluster number 7 shows the highest number of people who have not purchased the bike. So I'll say bike buyer low. Okay, so here I have bike buyer low and bike buyer high. Let's move to cluster profile, and we can have edge here. We can see the edge group, and you can see the breakdown of clusters, including bike buyer low here and bike buyer high here per edge. But let's move to cluster discrimination. In here on the cluster 1, let's put bike buyer high, and in cluster 2, let's put bike buyer low. So in this particular column, it is written favors bike buyer high, and we have a column here which favors bike buyer low. So we will find that, surprisingly, the first variable, okay, which favors people in buying bike is age group between 45 and above. So the age is the highest factor. You can see the age here between 45 and above are the people who have bought bikes more, and age between 33 and 44 are the one who did not purchase bike. But all in all, age is the factor. Again, number of cars owned. If people owns 2 or more cars, I think, then they will not buy a bike. And if people have one car, they are likely to purchase a bike. Okay, and again, we can see that North America did not purchase bikes, but in the other regions, people purchased a lot of bikes. And again, commute distance, if it is between 2 to 5 miles, then it favors it. It is a high factor in determining people purchasing a bike. If the distance is between 2 to 5 miles, but if the commute distance is between 5 to 10 miles, then people in this particular distance did not buy a bike. So we can see that the distance is a factor in determining the likelihood of someone purchasing a bike. And now again, if we move to naive Bayes, okay, now we have to remember that in naive Bayes we do not have yearly income or age. Okay, they were removed early on during our model choice. So we have all the other attributes except yearly income and age. Now, if I slide down this link, you'll find that if you use naive Bayes, the strongest attribute which the determinant factor for people in buying bike is the number of cars owned. Now, if you remember, in the decision tree, it was age. But because we don't have age here, then I think that's why number of cars owned became second. Now, if we drag it up, commute distance is also a strong factor. How far you live from where you work. It is a determinant of buying a bike. Okay, English education, the number of children at home, and then the least important factor is marital status in this case, and English education. So if you're married or not married, it's not a very important factor in determining if one will buy or not buy a bike. So this is in a nutshell, in a summary, is how we can determine how these models predict the outcome of data mining. The next stage is we are going to compare these three mining models to find which one is the most correct and which one we are going to use for our prediction. Now, after seeing how all the three models are working, then the next stage is to go to finding the accuracy of the model. Now, mining accuracy chart tab is located just after mining model viewer, and when you click it, the new page opens. On top we have input selection tab, live lift chart, classification matrix, and cross validation. Now we'll use input selection, and we'll leave synchronize prediction columns and value checkbox checked. And below we are going to select, in the select data set to be used for accuracy check, we'll use mining structure test cases. Now, in the predict value, we want to predict 1. That is, we want to select only people who will purchase a bike. So in the predictable column, we have bike buyer, okay, and the value of 1. So it means that only those people who have purchased the bike will be tested. And we want to test all the three models, which are decision tree, clustering, and naive Bayes. So after selecting this, I'll click the lift chart to show the accuracy. Now, in the lift chart, data mining lift chart, we have, if you can see clearly, we have 5 lines. The bottom line is called random guess, and the top line is called ideal model. Now, the anything in between, for example, the higher the line is, the higher the line, that this line is nearer to the ideal model. If, for example, let's assuming that this line here, which is random guess, represent pass mark. Okay, this is pass mark, and anything above the pass mark it has been passed. Okay, so anything above the pass mark is called a lift. Okay, so the line higher, the highest line, that this is the line which has passed more, which has more marks than the others. And in this case, if you look at the random guess model, the next line is clustering. Okay, clustering followed by naive Bayes, and the top or the best line is decision tree. So we can say that decision tree in this case outperformed naive Bayes and clustering in terms of accuracy. So if you want to use a model, a data mining model in this case, to predict the likelihood of people buying bikes, then the best model to use is decision tree. Now, there are more things in testing for accuracy than what I've shown here, but because this is only a demo to give you an insight of how things work, I'm sure when you have time, then you can explore more and learn more about testing the accuracy of the mining structure and mining models. So this will be the end of video number 2, and in video number 3 now we will use the decision tree now, because now we are sure decision tree is better off in this case than naive Bayes and clustering in determining people who are future customers who are likely to purchase a bike. So thank you for watching video number 2, and I'm sure after watching video number 3 then you'll understand better how this works.